let's work through an example. I actually took an example here from a little bit different book than our book. So sorry, didn't like the one in the book. So this is a little different. So we're working through an example for finding a confidence interval for a proportion. Okay, we have here, I have here a little bit of a, let me see if you can see the question. Okay, so reporting cheating. Students are reluctant to report cheating by other students. A student project put this question to an SRS of 172 undergraduates at a large university. You witness 2 students cheating on a quiz. Do you go to the professor? Only 19 students have answered yes, and they ask us to give a 95% confidence interval for the proportion of the undergraduate students in this university that would report cheating. Okay, so before I can go and use my normal distribution, I have to go and make sure that I'm meeting some of those conditions. But because if I'm not meeting those conditions, I cannot use my normal distribution in order to use my z-score, my critical z-value. Okay, so our first thing that is important to me is that this data comes from a random sample. Is it random? Well, there is something over here that tells me that this is SRS. So they have randomly have sampled their students. Another thing that is important for me is the 10% condition, that if I am sampling without replacement, that I am not exceeding 10%. And this is where this is important, that they tell us that this is a large university. If it's a large university, then when I'm taking 172 students, I am not exceeding 10%. And the last condition that is important for me is the large counts. Is the number of successes and the number of failures, it actually exceeds 10. Well, let's see. Number of successes over here for us, people who did report cheating, is 19. Is it greater than 10? Sure it is. And 172 minus 19, that's 53. Then that number, or whatever that number is still greater than 10, okay? So this is 172 minus 19. Yeah, it is greater than 10. So since each and every one of those conditions is met, I can go ahead and use my normal distribution. Use normal distribution. Okay. Using normal distribution means that I'm going to be able to go ahead and use my z-score. So I'll remind you that in order to build a confidence interval, I need my point estimate. Okay, I will need my z-score, my critical z-score, z over alpha, and I would also need my standard deviation of the sampling distribution. And this is the square root of p hat q hat over n inside the square root. Okay, so let's go ahead and put all those values in there. But before I'm actually going to begin, let's calculate my p hat really quickly. What is p hat? P hat for us is the 19 people that did report the cheating out of all the students that have been picked out for the random sample. So 19 out of 172, that makes it 0.11, 11%. That means that the failures, people who did not report the cheating, is going to be 1 minus the successes, which is going to be 0.89. Okay, so my p hat over here is 0.11. My z, my critical value z, since they have asked me for a 95% confidence interval, you can look it up in your z chart, or if you remember it by now, is 1.96 for 95%. Okay, and now I would have to do this whole business over here, and this is 0.11 times 0.89 divided by 172 people, all that in the square root. Okay, so I'm going to be doing 0.11 minus 1.96. This business over here turns out to be 0.0238. Okay, and that turns out to be 0.06. Okay, and the second time I'm going to be doing 0.11 plus 1.96 times 0.0238. Okay, so this is my margin of error, and this is where I'm doing this. One time I'm subtracting and one time I'm adding. And that business over here turns out to be 0.1566. So I'm just going to round it to 0.16. Okay, so there you go. I'm going to be 95% confident. I am 95% confident that the interval this interval 6% to 16% is going to capture the true proportion of people willing to report cheating, or students willing to report cheating. And this is what we've got there. This is it for confidence intervals for proportion. So this is actually turns out to be a little bit simpler than for mean, but that's what we've got.